Hello students. So in the last lecture I have told you about the code memory of the PIC microcontroller. So I have already told you that which type of memory is available. So code memory or program memory are available in this slide. So you can see that different type of memories are available for different type of PIC architecture. So now let's see the data memory or the RAM for different type of architectures for the PIC microcontroller. So it is also known as file register, okay, or for RAM it is the file register or RAM are over there. So for 12C508 only 25 byte RAM is available. 16C71C has 36 bytes of RAM available. 16F877 has 368 byte RAM plus 256 byte of non-volatile EEPROM, and 176677 has 902 byte of RAM is available with the memory. So there is a PIC programming procedure. Now let's see what are the PIC programming procedure. So for example, in programming an embedded PIC featuring electronic erasable programmable read-only memory. So on a PC, type the program, successfully compile it, and then generate the hex file as we do in the 8051. Using a PIC device programmer, upload the hex file into the PIC, and this is step into the burning. It is also called as burning. Now insert your PIC into your circuit, power up, and verify program works as expected. This steps is often called dropping the chip, and if it is not, you must to go to the step 1 and debug your program and repeat the burning and dropping process. Okay, so that's how we just program a PIC microcontroller for our purpose. We can say that any type of microcontroller work like that, and we should follow them for our successful programming. So what are the features of the PIC? So that is a standard PIC IC, PIC 16F877A. It is a standard PIC IC, and it is a standard microcontroller used for the purpose of embedded coding. So high performance RISC CPU is there. Only 35 single word instructions are there, and you know that in the 8051 there are so many instruction sets are over there. For each and every task there are different type of instructions, which is not in the PIC type of microcontroller, and it is a RISC type, and it is reduced instruction set computing. So only 35 single word instructions are over there. So only single instruction can do multiple tasks. So that's why it is a RISC type architecture. All single cycle instructions except for the program branch, which are of 2 cycles. So all the you can say instruction cycles except call instructions and all jump instruction, all has the 2 cycle instructions. So operating speed is of 16F877A is 20 megahertz. Clock input DC is a 200 nanosecond instruction cycles. Okay, it is a pin diagram of PIC 16F877. So first pin is memory clear or VPP pin. It is used for the purpose of the burning the PIC microcontroller also, but VPP is the power supply to this pin, so we can use it for the power supply to it also. So there are different type of the pins available for this purpose. So AN0, AN1 are the analog pins, so we can provide the analog to it. So it has the bi functionality. So RA0, RA1 is the another thing, and it is also counted in a port. So RA0, RA1, RA2, RA3, RA4, RA5. Okay, and so these 5 pin ports are available as A port of the 8051, sorry, 16F877A, and then E port is available is over there, and including read write cycles are over there, chip select, read write. So external RAM or ROM we can include in it. So AN0, AN1, and after that AN2, AN3. So these all are the analog pins, and we can interface any analog AN4, AN5, AN6, AN7. So all the analog sensors we can interface with it. VDD and VSS are the power supplies to it. VPP has and MCLR has the dual response of this pin, and it can, you can say, it can store the program as well and it is used for the burning purpose of the ROM. These are the oscillator pins. Pin number 13 and 14 are the oscillator pins. Clock in is for the oscillator pin for the input, and clock out, if there is a master slave configuration, then this clock out is used for that purpose. Then C port is over there. This is also come in picture with the E port. So another is the C port is also there. So RC0 to RC3, you can see that these 5 pins are over there for that purpose. And different, so it has the SPI communication also, serial peripheral interface. So it has SCL, CCP1, CCP2, this type of things are also available over there. So RD0, PSP0, RD1, so D port is also there, RD till the RD7. So 8 pins are 5 pins are there for the purpose of this purpose for the D port. And then we have some pins of the RD port are also available at 27 to 30, and it is RD4, RD5, RD6 and RD7. So total 8 pins are available for the D port. And then we have C port. So some of the C port are in this PIC microcontroller are there. RC0 to RC3, then RC4 to RC7 are also there. So RC port also has the 8 pins. So SDO, SAL or SDA, these are the SPI interfacing. TX, RX are the UART for the UART configuration, and PS, PS4, P4, P5, P6, so power supply. These are used for the purpose of the another type of the communication, which is for the serial communication and used for the SPI communication. And VSS and VDD again are short with the VSS and VDD. All these pins are short with the VDD is for the positive and VSS is for the ground. And then RB port is also there, which has the 8 pins from 33 to 40. So these pins are used for the purpose of the interfacing, and we can use them easily. So now this is a important it is showing that how it is working actually. Okay, so now it is a PIC memory. So PIC memory has 8 kilobyte of memory, and it has a 14-bit instruction program memory. So 368 byte registers as data memory, and it has the special function registers used to control the peripherals and PIC behavior. It has the general purpose registers used to in normal temporary register. So 256 bytes of the non-volatile EEPROM also is also over there. So that is the PIC data memory. So you can see that there are different type of registers available, and you no need to go in much details of it. It is just for your information. And now PIC family control register, status interrupt control option register. So these are also available for this register. So this is the so some peripheral features are also there, which is important as per your curriculum and syllabus. So in this case you can see, so these are the peripheral inter features, and which has 5 digital input output ports, 3 timer counters modules, timer 0, timer 1, timer 2. It is timer 0 is 8-bit timer counter and with 8-bit prescaler, 16-bit timer counter, and can be incremented during sleep via external crystal clock. and timer 2 is a 8-bit counter with a 8-bit period register. So you should cramp all these things because it is important as per your exam. And a 10-bit ADC is also over there to capture compare pulse width modulation. Modes are also there. Synchronous serial port is there with SPI master control and I2C. Both things are available in this. All types of the PCB control, PCB communication protocols are available in this microcontroller. USART SCI microcontroller is also over there. PSP 8-bit wide and external RD write and CS control is also in this PIC microcontroller. So it is important as per your exam, and I think it is enough. And next I will tell you about the more about the PIC microcontroller if I will get my time. So thank you for this lecture. So your unit 2 has been completed in this after this slide. Thank you.